Agrisea is a company driven by a commitment to provide sustainable solutions for land-based production through the use of sea-derived products. The company has recently teamed up with University of Waikato scientists and other stakeholders to investigate the use of algae to extract excess nutrients from water before it's returned to the ocean.
We have large amounts of nutrients running down our waterways. Nutrients aren't bad, but excess of them in the wrong place is not always a good thing. So for us, this project is around mopping up excess nutrients coming down our waterways. And more importantly, we also operate at the top of the cliff, so back in the farm paddock, back where we can reduce the amount of nitrogen going into the system in the first place. But whatever escapes that system, let's try and clean it up at the river mouth as well. This project is a pilot, so first of all, seeing if we can grow sea lettuce in these operating systems from a diffuse source. When we scale it up on a hectare, that produces around 35 tonnes of dry weight of ulva or sea lettuce per hectare. Currently, we're drying that and looking at extracting some of the high-value goods, such as olivins, which are these incredible bioactives. But there's also beautiful proteins, there's ingredients for skincare, for biostimulants, for plant additives. There's a whole range of ways that we can create commercial value from this ulva. And that's really the stage 2 of our partnership with the University of Waikato.
Let's have a look.
This project is more than research for research's sake. It's actually around practical application. How can we get these tools into the hands of people who will use them? So going forward in terms of scaling up with the University of Waikato, they will help us and train us and technicians to create hatcheries of local spores of seaweed that we can feed these systems.
Quite different from the covers that we got. Ulva, the sea lettuce, is really excellent for growing in these land-based systems. And so this is a species that we've been working with for decades now in my research group. So it grows really well, free-floating, like they have to do in these sort of ponds. You find it free-floating out in the natural environment as well. It's a bloom-forming species in the environment, and while that may have negative connections from sort of ecological perspectives, in a farming perspective, it's fantastic because you want something that grows really well. And because it grows so well, it also takes up nutrients really fast. And so that means it's really good for these bioremediation purposes. And then there's a whole raft of applications from the actual produced biomass as well, which is a real bonus, of course. So bioremediation at that really high level is using any organism to grow in a water body to clean up nutrients. So in our case, what we do here is we use seaweed to grow it in the water to clean up primarily nitrogen and phosphorus from the water here. So it's possible to do this pretty much anywhere where the seaweed grows naturally, and ulva sea lettuce is really spread all around New Zealand. What we do find though, even here, is that it grows better during the spring and summer months where you've got more sunlight and it's warmer and all those things. So you would just have different rates of productivity and nutrient remediation during different seasons. And so probably at the further south, you'll have a shorter high productivity season than you do up here. But there's those sort of trade-offs that you'll need to make. We have the mature seaweed that we get to reproduce. So this is a mature piece, and we stress it so it releases its tiny little spores that are microscopic. And then after a while, these tiny microscopic spores, they settle together and form what we call germling clusters, which are basically the little seedlings. And these are what they look like when they are just a little bit older. And so we let them grow to at least a centimetre or 2 before we take them out here, so that they don't pass through the filter in the ponds and run out in the discharge water.
It's growing so well. I have an intake site about 300 metres down the way. It's on the edge of the Waiho river mouth, about 150, 200 metres from the edge of the river itself. So it's on the edge of a tide gate there. So I pump at high tide to ensure that I get the most salinity. So the water gets put into our big storage tanks behind us. It goes through a sand filter to remove any suspended solids and sediments, and then it's put through our high rate algal ponds here. For the pilot trial that we're running, we've done 4-week blocks with weekly harvests. In winter, sort of up to 2.5 times its weight in a week, and then in summer it gets right up to almost quadrupling its weight in just a week. When we harvest, the tanks get drained into a sump, and we've got a collection bag at the end of that which catches all the seaweed and then allows the water to get pumped basically right next door to where it's taken from in the first place. And then I lift it a little bit and then let the water drain, and a little bit more and let the water drain further. So I take the bag of seaweed out of the sump and I take it over to our high-tech dewatering device, which is just a fancy word for a spin cycle on a washing machine. And then from there it gets taken back to Agrisea and then we dry it right out in an oven.
We've had 2 years of operation. We've called hui and gathered a whole lot of different people from different areas and industries and really showcased some of the results that these are having. And again, we're getting the same type of feedback, really in behind you. How do we get this to hectare scale, and how do we keep making, or make more of an impact than what we're already doing on this pilot scale? The trial itself has been unbelievably successful. At the end of the day, this money was public money. The majority of it was from the Aotearoa, Sustainable Food, Fibre and Futures Fund, and alongside some other amazing partners. And we just truly believe from the get-go it was an environmental project first and foremost, with some commercial opportunities and outcomes, secondary. We have already been talking with ECAN down in Canterbury. We've been talking to some of the team from Wairarapa Moana, really looking at similar systems or setups that could essentially be plug and played in their neighbourhood and create the same or if not a similar impact to what we're finding here in the Firth. So my dream is to see these systems all around our country doing the bioremediation and the clean up that they're built to do.